welcome to video instruction. For those of you that haven't watched an instructional video before, some hints or tricks on this. So first thing to think about is to watch it all the way through once, get an idea of what it's talking about, what the subject matter is, where things are located, and then go back and watch it again and take notes. And just like you would, that brings up the second thing, just like you would in class, write down the things the presenter is talking about and showing you on the screen, and write down questions that you have that come up, and write down things that are new to you. The third thing to think about or to write down is to go back and watch it again, see if there's anything that you missed, or if there's any answers to your questions that you may have missed as you came up. So that's another thing as you do it a third time. Fourth thing is to write down your questions and send those off to the presenter if you can. And the power of this really falls into, you can pause. So don't be afraid to pause when the presenter says pause, or when you feel like you need just a break to capture some stuff that are written down. Okay, so those are some helpful hints, 4 helpful hints to get you through video instruction. Hello, welcome, guten tag, guten morgen, depending on where you're at. Hopefully you're watching this at home on your Chromebooks or on your phone or on a computer at home. If you're watching this in the classroom, hopefully you got your earbuds in so you can hear me rather well. This video is split into 3 parts. You can watch it all the way through, although it will be rather lengthy. You should be taking notes, or you can split it up into 3 different sections, 3 different parts. I wouldn't spend 3 days watching this video though. I would get it done in maybe 1 or 2. Okay, I hopefully have started part 1 in class. If not, if I have, this will be a short review. If I haven't, well, here we go. All right, so we're going to be talking about engineers and engineering careers. We're going to be preparing for a poster. You're going to be doing some research on different engineering careers. And I want you to go in this with an open mind. I know some of you may have your careers already picked out. You're going to be the next Adrian Peterson as a football player, Mira Sorvino as an actress, or maybe you're going to be the next Mia Hamm as the soccer star. I don't know. Some of you may be going, who are those people? Well, you have to realize I'm 47, so my examples might not be people you know. That's okay though. It's okay to have a fallback career as well. I know I oftentimes joke, I could look at a career, my fallback career would be a professional wrestler if this professional teaching gig doesn't pan out, but so far it's doing really well. I also want you to be open-minded to the type of engineer. I know when I was your age, I was thinking, the type of engineer that I saw every day, a sanitation engineer, garbage person, or garbage men. I thought, oh my gosh, what an awful job. They must not make any money. They have to drive around and deal with people's stinky, ugly, icky, gooey trash. Then I looked at how much they made, and back in the 80s when I was in middle school, they were making $50,000, $60,000, $70,000, and back then that was a lot of money. And they got off midday. They didn't have to work. They started early in the morning, but they got off pretty early. So the more I thought about it, I was like, man, I'd love to be a garbage man, drive around all day and pick up trash. And now they would have to, back in my day, they had to hoist the cans into the back of the truck, so there was a lot of physical labor. But nowadays they've got the little robot arms that pick it up and put it in there. So let's go ahead and delve into engineering, build some background information on that, and hopefully hopefully introduce you to a different type of career. All right, so with that, part 1. This is where we're going to be talking about engineering in general, and some of the background information for engineers. All right, so I want you to think about this tool for a second. And in your notes, when I tell you to do so, I want you to write it down in your notes. So my tool helps me solve a problem, and that problem is communication. It helps me kind of be connected with my family on a daily basis. I can show pictures on it. It allows me to talk with my family rather routinely and nicely and very easily. It also allows me to play games on it. So I want you to go ahead and pause the video and write down what you think my tool is. All right, welcome back. I bet I know what most of you have put down. I bet most of you put down a phone, but here's my tool. It's a table. Okay? I can play video games. I could play board games on a table. I sit down with my family at night and talk about their day over dinner. I can print out and lay out pictures on the table. The point of this is, sometimes when we're thinking about solving a problem, sometimes the most efficient way is the lowest tech way. Okay? It's a rather easy tool to use and get. A lot of us have a table. You're probably sitting at a table right now. So think about that as we talk about engineering and the engineering process and what engineers do. It's not always the latest and greatest thing that solves the problem in the best way. Okay, some vocabulary for you to think about here. Engineer. You're going to hear me talk about engineer and engineering, and I want to get, where is it, my color here? I want to get blue. So you can also think of engineer slash engineering. Okay, E-N-G-I-N-E-E-R-I-N-G for those of you that were spelling along at home. All right, so the important part is they're into solving problems, designing ways, creating ways, and using creativity. Back to the previous slide. Creativity to solve problems. Okay, an invention. An invention is a new product, something that has never been seen before. I use the example here of the phone, and this is going to be my, poor example of a phone here, and I'm going to escape out of that. And then you can tell I haven't used my Wacom tablet here very much, but so here's an old phone. No, I don't want that. Okay, I'm gonna kind of, okay, there we go, old phone, and we'll put the little dial thing you have to do there. So there's an old phone. Okay, back in the olden days, before telephones, you either had to write out your letter, and writing a letter was expensive. You had to pay a person to get on a horse or a carriage and send it across the country, or send it across the town, or down the street. Or you actually had to get up out of your chair, go down the street, talk with your friends, or invite them to your birthday party. You didn't text them. You didn't just put together a little 3x5 card and hand it out at school. That was expensive. You actually talked to people. Well, then you have an innovation. Innovation is a redesign of an existing product. It's improving something. When we talk about phones, we talk about the latest and greatest thing called a cell phone or a smartphone. Okay? And in my day, smartphones were oftentimes flip phones, or they didn't have texting, or they didn't have video. You couldn't connect to the internet. Everything was done over a cellular network. So as I showed you here, an invention is a never before seen product, the invention of the telephone. The innovation, redesign or changing of that with the cell phone. All right, moving right along. Get my laser pointer back. Bammo. And so STEM, coming into that is, we oftentimes think of science, technology, engineering, and mathematics. What is this? What is STEM? You may hear this. Some of you may already know. In your notes, I'd like you to go ahead and write out the answers to these questions. What do you think they are? We're going to talk about them here in a second. So go ahead, pause your video and write out your answers. All right, welcome back. Let's see how you did on that next slide here. So science, technology, engineering, mathematics, STEM. So we have our scientists. They're the ones that investigate. They oftentimes find problems or decide whether something's a problem or why something is happening. There are investigators. Then we come down to our mathematicians that work on taking the problems and applying numbers and mathematics and how much of a problem, how big of a problem it is. Sometimes we solve equations and all of that. We have the technologists that apply science and math to designs. They come up with ideas. They come up with ways to solve the problems that come up. And then we have engineers that put the technologists' ideas into practice or into a physical entity. All of that is put together in what we call STEM, where you have, and sorry, I got an itchy nose here. In STEM, where we're looking at solving problems, solving problems of people's needs and wants. And in a later part of the video, we're going to get more in depth into what needs and wants are. But that's how we use STEM, is to address the problems of people's needs and wants. One big one that's going on in STEM right now is how do we get people to the moon, and how do we get people to Mars? That's the next kind of big endeavor that is involved with STEM. Okay, so moving right along here. Okay, so let's think about creating a product, something that is a need, and it was a need and a want back then. Back in the olden days, we didn't have pencils. Well, in my day we had pencils. The trusty good old Ticonderoga #2. But back in the 18, 17, 16, 18, in early 1900s, all you had was pen and ink. You had a quill and ink. And sometimes a quill was a sharpened bird's feather, and you had ink. Ink is permanent, and it was permanent back then. There was none of this erasable ink or anything like that. You made a mistake, you crossed it out, and your paper looked all ugly and smudgy, or you threw it away and you started over again. Think about that. If you're writing an assignment in math, or you're writing a paragraph for, say, ELA, or you're doing a science data table, if all you had was ink and you had to crumple up and throw your paper every time you made a mistake, went through a lot of paper. So along came scientists, and they discovered something really cool, that graphite, not lead, we call it lead, but it's really graphite. Lead's poisonous. Found out that graphite would write and would make a mark, and you could use a rubber eraser to remove the graphite. Oh my gosh, that was life-changing for people back then. Along came the technologists and said, well, we could do that. We could create a device that's like a pencil, kind of like this sparkly little blue pencil here, that writes using graphite and erasers. The engineers said, well, okay, we can figure out how to take the graphite, put it into this wood cylinder, and how to get the little metal bracket here to attach the eraser to it. That's easy to build and make and create. Mathematician came along and said, well, how long do we need to make it? The quills were sometimes this big. Well, that's a lot. Maybe we make it this big so it fits in pencil pouches or fits in our pocket, and it's easy, and we don't want the great big huge super pencil that they sell at gift shops, but maybe we need something that can fit easily in our hands, like this stylus that writes on my Wacom. All right, so I want you to kind of apply what we've talked about here. What does the scientist, technologist, mathematician, and engineer do when it comes to the phone? What was their responsibility? So go ahead and start filling out this table as you pause the video. All right, welcome back. Let's see how you did. Okay, so the scientists discovered that sound travels in waves. We have sound waves, similar to the can and string. That's why that works. All that is a simple wire. We can send sound waves over wire thanks to the technologist. And even then, we can convert that sound wave into electric waves or electricity. That goes over long distances. And then the mathematician comes in and says, well, how far can we send that without it being distorted? Okay, so that's how STEM came into the phone. Okay, all right, so that's the end of part 1. We're going to get into part 2 here very quickly. Be a couple other small vocabulary parts that go with this, but we're going to get into problem solving. All right, so if you're just joining us back from the other video, welcome, or from part 1, welcome. Let's move into part 2. Part 2 is going to start talking about, if I had my pen here, go back to my pen, and I'm going to go pen, and I'm going to do this one in, I'm going to go green this time. All right, so in this section we're going to talk about needs and wants. And I want you to take a minute and I want you to list out 5 things you think you need and 5 things you want. So go ahead, pause the video and create your list. All right, welcome back. It'd be interesting to see some of the needs you get, but I want you to think of your needs and compare them to the definition of a need. A need is something that is a must-have to survive. You've got to have it to survive. Now I know my 7th grader, my 13-year-old thinks she needs her cell phone to survive. And we're constantly reminding her, You don't need it to survive. Cell phone would be more like a want. These are things that make life, that's an F. These are things that make life better. That cell phone fits into that want. It makes life better for her. All right, so this is the definition of needs. This is the definition of wants. Let's go ahead and talk about those a little bit. I'm going to erase that so it doesn't clutter up my slides here. Okay, so problems that solve our needs and wants. What do we think some human needs are? Well, humans need basic shelter. We need a place to hang our hat, so to speak, or go and get out of the elements, get out of the weather. And you can see kind of a basic little hovel here. We need clothing. We need basic clothing. And other physical needs that we want, that we have. For some of us, it might be transportation. And that's a physical need. Where's my pointer or my mouse here? Let's go down here. All right, biological needs: food, water. Okay. These are things you got to have to, as I like to say, you can go 3 days without water and 7 days without food. These are biological needs. Psychological needs: we need family to protect us, family to provide for us. We need friends. Some recent reading that I've done, research I've done, is we have a physiological need to be social, to be connected to people. Okay? So these are our needs. As we continue on, what are some wants? Okay, what are human wants? Well, sometimes we want a nice house. Sometimes we want a bigger apartment. Sometimes we want a bigger car. Sometimes we want a Corvette versus the truck that I drive now. We want nice clothes. We don't need nice clothes. We want nice clothes. Okay? I think sometimes we lose sight on that. All right, moving right along. Biological wants. We want fresh water. We don't need fresh water, but we want fresh water. Fancy food. I want lobster. I don't need it to survive, but I want it. Hey, healthy living, and oftentimes psychological needs. We want to be able to talk with our family. We can survive without talking with our family, but it's a want. Sometimes we want to see our friends. We want entertainment. We don't need entertainment to survive. Okay, so engineers come in. This is where engineering and engineers come in. They help us look at ways to solve these problems, and taking science and technology and putting it all together to solve the practical problems that are out there. And there are all sorts of different types of engineers that help us with these problems and solving the problems of our wants and needs. Okay. Engineers, there are different types out there. You may think of an electrical engineer that wires up a house or wires up a car, or can interpret a wiring diagram to repair our dishwasher or repair our cell phone. Those are electrical engineers. A pharmaceutical or chemical engineer may be looking for a cure for cancer or better vitamins, or a petrochemical engineer looking for a more efficient fuel or ways to use oil better. A computer engineer, how do we take smartphones and turn them into watches? Or, as I've started to hear about, how do we take watches or cell phones and put them into smart glasses? These are ordinary reading glasses, so you don't get freaked out, but how do we take those Apple AirPods and make them even smaller so that they fit inside our ear so we don't even see them? That's computer engineers. Okay? A mechanical engineer, robots on Mars. How do we, nanobots, how do we make robots smaller so they can go into our body and find invading viruses or cancer cells and destroy cancer cells? We see that in science fiction, but sometimes science fiction mirrors reality in some ways. Then we have agricultural engineers. These are the engineers that are looking at farms and farming techniques, and how do we make them better? How do we maybe take farming techniques so that we can do hydroponic gardening in inner cities or in urban areas as opposed to rural areas like in eastern Washington? How do we make crops grow as our climate continues to change? How do we improve growing crops as our climate continues to change? Basically, engineers are working to make our lives better. And that's what we're going to be focusing on in part 3, is the different types of engineering careers that are out there. Okay. Welcome to part 3. This is the last part where we're going to talk about engineering careers and job posting. A job posting is basically an advertisement. It's advertising a job. It's kind of like a commercial for different types of jobs. And out there, within that advertisement, it talks about what do you need for the job, what does the person do for the job, where is it typically located. You may think that's strange, but when I talk about location, you really don't find a lot of oil engineers or petrochemical engineers out here in the Northwest. You see them out in Texas or Wyoming where there's a lot of oil going on. You also may find a lot of software engineers here in Seattle with Microsoft and Google and Facebook and Amazon, but you don't find a lot of them out in North Dakota and South Dakota. Okay, so you may find engineers in pockets everywhere around the world, but really typically location, they kind of congregate around things. You find a lot more teaching careers or teaching jobs in urban, suburban areas, not so much in rural areas. There are teachers in rural areas, but usually they're in around cities. And a job posting also tells you what's available, what kind of jobs are available. With a job posting, there's really four main parts. There's a description, like I said, tells you what you're going to be doing for the job, what the hours are, how long you're going to be doing, what are the typical duties. Then you have experience and education. How much experience do you need for this job? How much education? How much schooling? What types of schooling do you need? You have pay. What's your salary going to be? What's your hourly rate? What are you going to get compensated? What are your benefits that you get from this? And location, where are you typically going to be working? Is it a work from home type job? Is it a job where you got to relocate to a suburban area, or you got to move downtown, or you got to move to a different country? What's the location? So you're going to be creating these things, and just to help you with that, let me get my pen out again here. So description is kind of, what do you do? There's that little, oops, try that again. So what do you do? What are your responsibilities? What are your responsibilities? Experience and education, type of schooling, what degree do you need, how much experience. An example of this might be a HVAC technician. You really only need 3 years of trade school to learn how to work with sheet metal and work with some of the systems. But the big part is experience. You need to get out and do work as an apprentice and work as a low-level employee to learn the tricks of the trade, so to speak. Pay. This is the money, but also something that we call benefits. Okay. Do they give you retirement? Do they give you health care? Do they give you 401k? What are the perks? And location, this is where are you working at? Okay, so these are, and location, as I said, can be more than just a physical location or a city or urban type location. It could be, are you working from home or are you having to commute in every day? Okay, so as part of this assignment, the assignment is going to be creating a job poster, and you're going to have 5 parts to this job poster. And I'm going to switch my pen here to a different color to make it easier to read. So with this, kind of the part I didn't put in here, and I'll just carve it out. I really don't care how you organize your poster, but it should be organized where you talk about the 4 things plus an extra one. So the part I left off of this is experience / education. Okay. This will need to be a paragraph along with the description and the location. These 2 down here, pay scale, inventions and innovations, can be a list. Okay, and with this one, you're going to see, with pay scale, you're going to see 3 levels. You're going to have entry, mid-level, and experienced, or high level, or upper level. Entry level would be just starting out. Mid-level would be 5, 10 years in. Upper level would be 10 plus, 20 plus years. Inventions and innovations. I want to know a list of things that this type of engineer has invented, and I want to know a few things that they've innovated, that they've improved upon. To help you with this, in the assignment in Google Classroom, there is the procedure. There's also what we call a Prezi of engineers, types of engineers, A to Z. Okay. Everybody in the class will need to pick a different type of engineer. I know there's only 26 letters in the alphabet, and there's sometimes 36, so there will be some doubling up of engineers. That's fine. This is an individual activity, though. We're not working together. So if we have 2 electrical engineers, that's fine, but I don't want you working together. You're doing your own work. Paragraphs will need to be in your own words, not copying and pasting into the poster. You can include pictures that support the parts here. It'll need to have a little title of your engineer and then broken into parts. The poster itself, this part here, the poster will need to be no bigger than 3 feet long by 2 feet wide. The poster paper or butcher paper underneath the stairs in the library is perfect. It's 2 feet wide. Just rip off approximately 3 feet, you're good to go. You can use other materials you have on your own or that you want to go out and purchase on your own. I am supplying butcher paper or poster paper. That's it. Okay. Oh, I will also supply the printing of the materials, or printing out pictures and printing out your paragraphs and your lists. If you want to handwrite it, that's fine. What we're going to be doing with these next week, we're going to have a gallery walk, and we're going to be doing what I call Engineering March Madness, where we're going to pit engineer versus engineer, and the class will decide what is the top type of engineer at Surprise Lake. Okay, there's more information on the assignment listed in Google Classroom. Feel free to email me with questions or concerns or comments or wants and needs. I look forward to seeing what you put together. Again, the poster is due next week on Tuesday. Good luck, and as I always say, go forth and do great things.